Are you looking for a video about laws of exponent? Then this video is right for you. So, without much further ado, let's begin. Hi, my name is Rowel Carpio, a math teacher and a coach, and I do math tutorial in my YouTube channel. In this video, I'm going to present to you laws of exponent. What are exponents? Exponents are also called powers or indices. The exponent of a number tells how many times the number called the base is used as a factor. For example, 4 raised to the power of 3 is equal to 4 times 4 times 4, which is equal to 64. The base 4 with an exponent of 3 is read as 4 to the third power or 4 raised to the power of 3. Since the exponent is 3, hence the base 4 is used 3 times as a factor. Exponents save space from writing long repeating factors. So what are the different laws of exponents? We have here number 1, product of powers. If A is a real number and M and N are integers, then A raised to the power of M times A raised to the power of N is equal to A raised to the power of the sum of M and N. So to multiply with like bases, add the exponents. So for example, 2 to the third power times 2 to the fifth power is equal to 2 to the power of 3 plus 5, which is equivalent to 2 raised to the power of 8. Another example, we have here the quantity of 2 over 3 raised to the power of 4 times the quantity of 2 over 3 raised to the power of 9 is equal to the quantity of 2 over 3 raised to the power of 4 plus 9, which is equivalent to the quantity of 2 over 3 raised to the power of 13. Number 2, quotient of powers. If A is a real number and A is not equal to 0 and M and N are integers, then A raised to the power of M over A raised to the power of N is equal to A raised to the power of M minus N if M is greater than N, and A raised to the power of M over A raised to the power of N is equal to 1 over A raised to the power of N minus M if N is greater than M. So to divide with like bases, subtract the exponents. Okay, let us have examples. We have here 7 raised to the power of 5 over 7 raised to the power of 2. So that is equivalent to 7 raised to the power of 5 minus 2, which is equal to 7 raised to the power of 3. But if we have 7 raised to the power of 2 over 7 raised to the power of 5, that is equivalent to 1 over 7 raised to the power of 5 minus 2, which is equal to 1 over 7 raised to the power of 3. Now, let us have number 3, the power of a power. If A is a real number and M and N are integers, then the quantity of A raised to the power of N raised to the power of M is equal to A raised to the power of M times N, which is equivalent to A raised to the power of Mn. So to find the power of a power, multiply the exponents. So let us have examples. We have here the quantity of 3 raised to the power of 4 raised to the power of 2. So we just simply multiply 2 times 4 to give us 3 raised to the power of 8. Since 2 times 4 is 8. Example number 2. We have here the quantity of 10 raised to the power of 7 raised to the power of 5. That is equivalent to 10 raised to the power of 5 times 7. And 5 times 7 is 35. That's why our final answer is 10 raised to the power of 35. Let's have number 4. We have here, if a and b are real numbers and m is an integer, then the quantity of a times b raised to the power of 5 is equal to a raised to the power of 5 times b raised to the power of 5. So to take the power of a product, multiply the powers of the factors. So, for example, the quantity of 3 times 4 raised to the power of 2, that is equivalent to 3 raised to the power of 2 times 4 raised to the power of 2. Example number 2, we have here the quantity of 5 raised to the power of 3 times 7 raised to the power of 4 raised to the power of 3. That is equivalent to 5 raised to the power of 3 times 3 times 7 raised to the power of 3 times 4, which is equivalent to 5 raised to the power of 9 times 7 raised to the power of 12. Since 3 times 3 is equal to 9 and 3 times 4 is equal to 12. That's why the exponents are 9 and 12 respectively. Let's proceed to number 5. Power of a quotient. If a and b are real numbers and b is not equal to 0 and m is an integer, then the quantity of a over b raised to the power of m is equal to a raised to the power of m over b raised to the power of m. So to take the power of a quotient, multiply the power separately to the power of the numerator and the power of the denominator. For example, the quantity of 7 over 8 raised to the power of 5 is equal to 7 raised to the power of 5 over 8 raised to the power of 5. Number 2 example. The quantity of 3 over 2x raised to the power of 4 is equal to 3 raised to the power of 4 over 2 raised to the power of 4 and x raised to the power of 4. Since 4 is distributed to each component of the denominator, which are 2 and x. Number 6. Zero exponent. If a over b is a non-zero rational number, then the quantity of a over b raised to the power of 0 is equal to 1. So any non-zero rational number raised to 0 is 1. So for example, 120 raised to the power of 0 is equal to 1. While we have also the quantity of negative 2/3 raised to the power of 0 is also equal to 1. Number 7. Negative exponent. For any non-zero real number a and any positive integer n, the quantity of a raised to the power of negative n is equal to 1 over a raised to the power of n. So in other words, if a non-zero real number is raised to a negative, we have to take the reciprocal of the given number for the exponent to become positive. Let us have examples. We have here 7 raised to the power of negative 2. That is equivalent to 1 over 7 raised to the power of 2. Since we take the reciprocal of 7 in order for the negative exponent to become positive. So let us have example number 2. we have here 2x raised to the power of negative 5 over y raised to the power of negative 3. So for us to simplify this sample problem number 2, we have to expand this given equation. This 2x raised to the power of negative 5 is just equivalent to 2 over 1 times x raised to the power of negative 5 over 1 times 1 over y negative 3. So, since the exponent of 2 is positive 1, so meaning to say that 2 will remain in the numerator. Since x has a negative exponent, so we have to take the reciprocal of x. That is 1 over x raised to the power of positive 5. And also, since y has a negative exponent, we have to take also the reciprocal of 1 over y, that is y raised to the power of positive 3 over 1, to give us 2 times 1 times y raised to the power of 3 will give us 2y raised to the power of 3 over x raised to the power of 5 times 1 will give us x raised to the power of 5. That's why we have this answer. So there you have it, the different laws of exponents. I hope that you have learned and enjoyed watching this video. See you again in my next video. Thank you.